Every Toyota on the road right now is running on borrowed logic, not borrowed parts, not borrowed oil, borrowed decisions. Your vehicle's engine control unit, the ECU, the central computer mounted in the engine bay, makes thousands of calculations every second based on data it collected weeks, months, sometimes years ago. Most of that data no longer reflects how your engine actually runs today. The result is wasted fuel, sluggish throttle response, rough idling, and performance that slowly degrades so gradually you do not even notice it happening. Dealerships know exactly what is going on. They see it every day on their diagnostic screens, but they will never tell you how to fix it yourself, because the fix costs them nothing and earns them everything. What I am about to show you is not a hack, not a modification, and not illegal in any state. It is a factory-designed function built into every Toyota engine control unit. Once you understand it, your engine will run like the day it rolled off the assembly line. Let us start with what the engine control unit is actually doing behind the scenes. Toyota's engine control unit, the ECU, is the brain of your vehicle. It manages fuel injection timing, ignition spark events, idle speed, variable valve timing through the VVTi system, throttle body position, and transmission shift points. Every time you drive, the ECU collects real-time data from oxygen sensors in the exhaust stream, the mass airflow sensor mounted between the air filter box and the throttle body, the coolant temperature sensor threaded into the engine block, and the throttle position sensor built into the electronic throttle body assembly. The ECU uses all of this data to build what engineers call adaptive fuel trim tables. These tables tell the engine exactly how much fuel to inject and exactly when to fire each spark plug, based on your personal driving habits, your local altitude, your typical engine load, and even the quality of gasoline you have been using. In theory, this system is brilliant. In practice, it creates a slow poison. Here is why. Those adaptive tables never fully reset on their own. They accumulate corrections over time. If you had a slight vacuum leak 6 months ago that was repaired, the engine control unit, or ECU, still carries fuel trim compensation from that period. If you drove through a high-altitude mountain pass last summer, those altitude corrections are still influencing fuel calculations at sea level. If you used a lower quality fuel for a few tanks, the NOx sensor data from that period still shapes ignition timing today. Toyota designed the engine control unit to learn continuously, but it was never designed to forget. And that accumulated history is what silently robs your engine of the performance and efficiency it was built to deliver. This is where the reset changes everything. The procedure itself is straightforward, but the order and timing matter more than most people realize. The first step is to warm the engine to full operating temperature. This means driving for at least 10 to 15 minutes under normal conditions, not just idling in the driveway. The ECU needs the engine, the coolant, the catalytic converter, and the oxygen sensors all at operating temperature before any meaningful reset can take effect. Cold resets produce incomplete results because the ECU immediately begins compensating for temperature variables instead of building clean baseline data. Once the engine is warm, park the vehicle on level ground and turn off every accessory: the air conditioning, the radio, the headlights, everything that draws electrical load, then shut the engine off. Open the hood and locate the battery. On most Toyota models, the battery sits in the front left corner of the engine bay. Using a 10mm wrench or socket, loosen the bolt on the negative battery terminal, the one marked with a minus sign and typically a black cable, and carefully pull the terminal away from the battery post. Do not disconnect the positive terminal. Disconnecting the negative terminal is all that is needed to safely interrupt power to the ECU without risking electrical damage. Now here is the step that separates a real reset from a wasted effort. After removing the negative terminal, take the positive and negative cable ends, not the battery posts themselves, and touch them together for about 30 seconds. This drains residual electrical charge stored in capacitors throughout the vehicle's electrical system. Without this step, the ECU retains partial memory even with the battery disconnected, and the reset becomes incomplete. Many owners skip this and wonder why nothing changed. The capacitor drain is what clears the long-term fuel trim data, the adaptive idle values, the learned throttle position, and the stored short-term correction history. Once the cables are touched together briefly, separate them and leave the battery disconnected for a full 15 minutes. This waiting period ensures every module in the vehicle fully powers down and resets to factory default parameters. If you made it this far, then consider liking this video, giving it a thumbs up, and subscribing to my channel. This helps me bring you more honest car advice. After 15 minutes, reconnect the negative terminal to the battery post and tighten it securely. Do not start the engine yet. Turn the ignition key to the on position or press the start button twice without touching the brake. On push-button models, so the dashboard lights illuminate, but the engine stays off. Hold this position for 30 seconds. This allows the ECU to initialize its sensors, confirm communication with all modules, and establish baseline voltage readings before the engine introduces combustion variables. Skipping this initialization step is another common reason resets fail to produce results. Now start the engine, and this next part is critical. Do not touch the accelerator pedal. Do not turn on the air conditioning. Do not shift into gear. Let the engine idle completely undisturbed for at least 10 minutes. During this idle period, the engine control unit is performing its most important relearn sequence. It is establishing a new base idle speed by reading airflow through the throttle body, recalibrating fuel injector pulse width using live oxygen sensor feedback, and resetting the throttle position sensor 0 point. Every input during this window, even a slight tap of the gas pedal, introduces data that distorts the baseline calibration. The cleaner the idle, the sharper the relearn. After 10 minutes of undisturbed idle, turn the air conditioning to maximum. Let the engine idle for an additional 5 minutes with the compressor engaged. This teaches the engine control unit how to compensate for the parasitic load of the air conditioning compressor without affecting idle stability. Toyota engines that skip this step often develop a subtle idle dip or hesitation every time the air conditioning cycles on, a condition that dealerships frequently diagnose as a dirty throttle body or failing idle air control system when it is simply an incomplete relearn. Once this idle sequence is finished, take the vehicle for a calm drive of at least 15 to 20 minutes. Mix city and highway driving at moderate speeds. Avoid hard acceleration, sudden braking, or aggressive cornering. During this drive, the engine control unit is rebuilding its entire adaptive fuel map from scratch. It is learning your current oxygen sensor response curves, your catalytic converter efficiency, your transmission optimal shift points, and your throttle body's full range of motion under real driving conditions. The data it collects during this first drive becomes the new foundation for every calculation it makes going forward. Clean data, it means clean performance out. Now let me explain why this matters more than most drivers realize. Toyota's long-term fuel trim system is designed to keep the air-to-fuel ratio as close to the ideal 14.7 to 1 stoichiometric ratio as possible. When fuel trims drift beyond 5 to 8% in either direction, the engine is either running rich, wasting fuel and building carbon deposits, or running lean, creating excess heat and accelerating wear on valves, pistons, and catalytic converters. Over time, stacked corrections from old driving patterns, old fuel quality, old sensor behavior, and old environmental conditions push these trims further and further from center. The engine still runs, but it runs inefficiently. Fuel economy drops by 5 to 15%. Throttle response becomes mushy. Cold starts get rougher. Idle becomes less stable. And none of these symptoms trigger a check engine light because the ECU considers them normal adaptations. It adapted to dysfunction and called it acceptable. Dealerships see this every single day. When a Toyota comes in with complaints about poor fuel economy, sluggish acceleration, or rough idle, the first thing a trained technician does is check fuel trim data on a professional scan tool. If the trims are high but no fault codes are stored, the standard dealer procedure is to reset the ECU using their proprietary TechStream diagnostic software, let the engine relearn, and send the customer home with a bill for 1 hour of diagnostic labor. That bill typically runs between $100 and $200 depending on the dealership. The actual fix took the technician less than 5 minutes. The reset you just learned does exactly the same thing, for free, in your own driveway, with nothing more than a 10mm wrench. There's another layer to this that few people ever discuss. Toyota's electronic throttle body system, which replaced the old mechanical cable throttle on every modern Toyota, relies on learned position data stored in the engine control unit. Over time, carbon deposits build up on the throttle plate and bore, slightly restricting airflow. The engine control unit compensates by opening the throttle plate a fraction wider to maintain idle speed. This compensation stacks over thousands of miles until the throttle body is operating well outside its designed range. When you clean the throttle body without resetting the engine control unit, the computer continues commanding the wider opening even though the restriction is gone. The result is an idle speed that surges too high, sometimes by 200 or 300 revolutions per minute, and a throttle response that feels unpredictable. Resetting the engine control unit after cleaning the throttle body forces the system to relearn the correct position from a clean baseline. And the difference in throttle feel and idle quality is immediate and dramatic. The same principle applies after any maintenance that changes engine airflow or fuel delivery. Replacing the engine air filter, cleaning or replacing the mass airflow sensor, changing spark plugs, replacing oxygen sensors, servicing the fuel injectors, or even switching to a different grade of gasoline are all events that change the data the engine control unit uses to calculate performance. Without a reset, the engine control unit continues operating on old corrections that no longer match the current condition of the engine. The maintenance was completed, but the computer never knew it happened. This is why so many Toyota owners report that new spark plugs or a fresh air filter did not seem to make much difference. The hardware was updated, but the software was still running on yesterday's data. Let me address the concern that stops most people from attempting this. Some owners worry that disconnecting the battery will damage the engine control unit, ECU, void their warranty, or cause permanent electrical problems. None of these are true. The ECU is specifically designed to handle power interruptions. Every time a battery dies naturally, and every time a battery is replaced during routine service, The ECU goes through the same reset and relearning cycle. The process is built into the system architecture. No Toyota warranty has ever been voided by a battery disconnection because it is a normal and expected part of vehicle ownership. What you will lose temporarily are your radio presets, your clock setting, and your power window auto up and auto down memory. The radio presets can be re-entered in seconds. The clock resets itself on models with GPS or connected services. The power window memory is restored by fully lowering each window, holding the switch down for 2 seconds, then fully raising it and holding the switch up for 2 seconds. These are minor inconveniences that take less than 5 minutes to resolve. One important caution: on newer Toyota models from 2018 onward, disconnecting the battery alone may not fully reset all adaptive parameters. These models sometimes require a scan tool with bidirectional capability to command a full throttle position relearn. If you own a newer Toyota and notice the battery disconnection method does not produce the expected improvement in idle quality or throttle response, an OBD2 scan tool with throttle body relearn capability can be purchased for under $50, and it will handle the procedure without a dealer visit. The investment often pays for itself after a single use compared to what the dealership charges. The bottom line is simple. Your electronic control unit, ECU, was designed to learn and adapt. That learning is a strength when the data is clean and current. Over time, stacked corrections, outdated compensations, and inherited habits from past conditions can turn that adaptive intelligence into a performance anchor. A strategic reset clears the slate, restores factory baseline logic, and allows the engine to relearn using the cleanest and most current data available. It costs nothing, takes less than 30 minutes, and produces results that most owners can feel on the very first drive. This is not a trick, it is engineering. Toyota built the reset into the system because they knew it would be needed. The only question is whether you will do it yourself or keep paying someone else to push the same button. If you're enjoying this video, consider watching this one. It shares more secrets to help you outlast your Toyota engine.